Let's do one more example of finding the area between two curves, and this time let's do a trigonomic example. All right, so our two curves this time is 2 minus cosine x and then cosine x. And so let's look at the graph of those. Okay, the blue line on top here is 2 minus the cosine of x, and the black line is the cosine of x. And now, in GeoGebra, you can't really use the pi signs, but what I've done here is notice that they intersect here at 0, and then I put in the line that would be 2 pi, so to here, they intersect again. And our book also gave us this. They said to find the area between the curves from 0 to 2 pi, so that was kind of given. Notice that my 2 minus cosine x is the function on top, so it's going to be the function that I put first. So I have 2 minus cosine x, and then subtract off the bottom function, which is cosine x. And now I'm going to integrate that from 0 to 2 pi. Okay. Once again, like I did in my other examples, I can first simplify this algebraically. I get 2 minus cosine x minus cosine x, so it's going to be minus 2 cosine x dx. Notice that I can factor out a 2, and I can also pull that out front. Okay, so this is going to be 1 minus cosine x dx. Okay, and now I'm ready to integrate. I've still got my 2 out there, but this is going to be the integral of 1 is just x, and the integral of cosine is just sine, so this is going to be minus the sine x. Okay, and now I need to evaluate that at 2 pi and 0. So the first time through, I'm going to, okay, so the first time in, I get 2 pi minus the sine of 2 pi, but the sine of 2 pi is just 0, okay? And now my 2 is out front. And then here, I'm going to subtract off the 0 in for x minus the sine of 0, which is again just 0. So this all becomes 0. Okay. And so everything is 0 except for this 2 pi, so I'm left with 2 times 2 pi. So my area is in fact 4 pi. I hope this helps. Again, if you can figure out a way to get these graphed, right, so you can see, that'll make your life easier.